Section 1.7 has an evil title, Applications Using Venn Diagrams. Applications meaning word problems. And most of the stuff we do in Math 142, if I give an awesome lecture, if I give an awful lecture, the material's not that hard. You're probably going to get it regardless of what I do. Section 1.7 is maybe where I earn my money a little bit. Really, the material isn't that hard, but if I don't do a decent lecture, I'm going to make it harder than it should be. So I might have to do this lecture a couple times to get it just right. And a lot of the stuff that I have typed up that I used when I did the lectures the first time through, evidently isn't that good because more students missed the word problems on the test over this chapter than I'd like. So I'm just going to jump into it, and I'm probably not going to use a lot of the stuff I have typed up. And we'll just kind of see what happens here. So basically it says in this section we'll use Venn diagrams to solve word problems. We'll put numbers in the regions of the Venn diagrams that represent quantities as opposed to elements of a set. And we'll break 2 set Venn diagrams into 4 regions, 3 set Venn diagrams into 8 regions, and then I'm going to use the following numbering systems, and let me improve upon that by making some nice numbers that you're used to as opposed to as opposed to Roman numerals. So this is what we're going to do in this section in terms of the Venn diagrams. For 2 set Venn diagrams, we're going to break the diagram itself up into 4 regions. And let me just do them one at a time. I'll call this region 1, and this meaning that portion of the Venn diagram. And then I will call this region 2, and meaning that portion of the Venn diagram. This I will call region 3, which will be that region of the Venn diagram, and then the whole outside of the circles I'm going to call region 4. So in a 2-set Venn diagram, we're going to have 4 regions, and each of the regions, when we get to a word problem, is going to have a number put inside of them as opposed to elements of a set. For 3-set Venn diagrams, we're going to have 8 regions, and let me try to label the regions. I don't have enough colors to do 8 colors, but we'll see what happens here. I'm going to call this region 1, this region 2, and this region 3. Let me color up those regions for you. So region 1 is going to be that portion of the graph. Region 2, region 3, and then I'll come across and do 4, 5, and 6. And out of colors here, 4, and not sure how this is going to work. Oh, pink on pink, that didn't hardly show up at all. 5 and 6, and then 2 more we have, 7 and 8. 7 is going to be this bottom region, and 8 is anything outside the circles. So just to save myself some time, I'm not going to shade region 8. Region 8 is anything outside the circles. So 2-set Venn diagrams, we're going to have 4 regions to talk about, and 3-set Venn diagrams, we'll have 2 regions, or 8 regions to worry about. So let me make up some examples and or an example just to kind of help you understand how we're going to use the Venn diagrams in this section as opposed to how we used the Venn diagrams earlier. So let me just make up an example. So here's just an example that's not from my notes. We'll say, how about this? 100 students were asked whether they like Starbucks or Dutch Brothers. The results of the results are shown below. And we're going to show those results in the Venn diagram. And it's going to be a 2-circle Venn diagram as opposed to a 3-circle Venn diagram because there are 2 different companies students were asked about. So I'm going to make the left circle represent the students that like Starbucks, and the right circle the students that said they like Dutch Brothers. Let me just throw some numbers in here. So in my regions, there's kind of 4 regions. There's 4 numbers I need to plug in. I just plugged something in region 1, region 2, region 3, and region 4. I have to now understand, in terms of this problem, what the regions mean. So again, my regions are region 1, region 2, region 3, and region 4. For each of the regions, I'm going to tell you what the numbers mean if it's not obvious already. So in region 1, that 40 is inside the like Starbucks circle, but it's not in the part of the Starbucks circle that overlaps with the Dutch Brothers. So that 40 from region 1 represents 40 students who responded that they like Dutch Brothers, that like Starbucks, because they're inside the Starbucks circle, but they're not inside the Dutch Brothers circle. So, and I'll say and, I probably didn't need a comma there, they don't like Dutch Brothers. So done with region 1, I'll move on to region 2. The 30 in region 2, because that 30 is in the intersection of the 2 circles, the like Dutch Brothers circle and the like Starbucks circle. The 30 in region 2 represents the 30 students that like both brands. I'll just keep it short. For region 3, these 20, again, those 20 in region 3 are inside the Dutch Brothers circle, but they're not inside the Starbucks circle like those 30 were. These 20 in region 3 they like Dutch Brothers because they're inside the Dutch Brothers circle. They're outside the Starbucks circle, so they don't like Starbucks. So these are the 20 that like Dutch Brothers. But they don't like Starbucks. And then lastly, I don't have much room for this, for region 4, because this is outside of the like Starbucks and outside of the like Dutch Brothers, those 10 students in region 4, so the 10 in region 4, are the 10 students that don't like either. So that's how how I'd interpret the numbers in this Venn diagram. It's going to be important at some point when we're actually creating Venn diagrams that my Venn diagram matches the information that's given. The only information that I really gave in this problem, because I made up all the numbers, is that 100 students were asked. That means if I add up the number of students that I classify, those numbers have to add up to 100. And if you add up the 40 students, 30 students, 20 students, and 10 students, this adds up to 100 students. The numbers inside the Venn diagram needs to represent every, in this case, student that was surveyed. It can't have more than 100 students nor less than 100 students, or something is wrong. All right, so let's keep going with this. Now maybe let me ask some questions the best I can to help you with this. Some questions that relate to this diagram. So now that I understand the diagram, let me ask some questions. So how many students from the survey said they liked Starbucks? So I don't know if that's an easy question or a hard question. Let me just call this Starbucks and this Dutch Brothers. And to like Starbucks, that means you're a student that showed up somewhere in the Starbucks circle. Pictorially, the students that said that they like Starbucks are any of those students that are in the Starbucks circle. Some of them liked Starbucks and didn't like Dutch Brothers. Some of them liked Starbucks and they liked Dutch Brothers. The number of students that said that they liked Starbucks are the 40 that liked Starbucks and didn't like Dutch Brothers, and the 30 that liked both, because both of these sets of students liked Starbucks and they might have liked something else. The answer to this question is going to be those 70 students. Let me do another one. How many like Starbucks or Dutch Brothers? There's going to be some key words in our word problems, and one of the key words is the word or. And I'm going to think of the word or in terms of the Venn diagram as union. So what this is asking me is how many are in the like Starbucks circle union the like Dutch Brothers circle. So or is going to be union, and we know how to make graphs of unions to tell us the areas that are going to represent it. So for this particular problem, I have my like Dutch Brothers and my like Starbucks. To be counted, you have to like Starbucks or you have to like Dutch Brothers. If you're a student that likes Starbucks, that means you're in the Starbucks circle. So I'm going to count all those students for this because they classify as liking Starbucks. Because or is a union, I'm not going to do multiple colors when I go to draw the picture. For the like Dutch Brothers, I'm going to shade in the like Dutch Brothers. And any student that has been counted in either of these spots is going to be part of the answer to this question. So I need to add up the 40, the 30, and the 20 in regions 1, 2, and 3 to answer this question. And the answer to this question, how many students like Starbucks or Dutch Brothers, is going to be 90 because I think of or like a union. Here's another question. How many like only one of the two brands? Oh, that's not worded so well. Let me word that better. How about this? How many like exactly one of the two brands? This is more of an English question than it is like a set theory question. So when I look at my explanations, the 10 students that are in region 4 aren't going to get counted here because they don't like either. The 40 students in region 1, they like Starbucks and they don't like Dutch Brothers. They like exactly one of the two, Starbucks but not Dutch Brothers. So those 40 students from region 1 are going to get counted. In region 2, the 30 students in there like both brands. They're not going to get counted because they like 2 and not exactly 1. And in region 3, the 20 students that like Dutch Brothers and don't like Starbucks like exactly one of the two brands, and those are going to get counted too. The answer to this question, there's going to be 60 of the 100 students that were surveyed like exactly one of the two brands. All right, so let's do the same sort of thing now with a 3-set Venn diagram. And I'm going to try to use the example I have because it took so long to type this up. And let's see how this goes to try to explain to you the concept with 3 sets. And I don't know why all my examples are groups of students, but it is what it is. So this Venn diagram, this 3-set Venn diagram, says a group of students was surveyed to determine which of the 3 types of foods they liked. Some students liked more than one type of food. Some didn't like any of the 3 types of food. So there are 8 regions. Some students liked pizza. Some didn't like pizza. Some liked hamburger. Some didn't like hamburgers. And some liked tacos. Some didn't like tacos. And some maybe didn't like any of the brands. So now for each of the 8 regions, I need to explain what they are. So I'm going to go one region at a time. First thing I'm going to do is this region 1. And that's inside this pizza circle, so I know for region 1, those 4, they definitely liked pizza. Because that 4 is inside the pizza circle. It's not part of the hamburger circle. It's outside the hamburger circle and it's outside the taco circle. So they don't like hamburgers and they don't like tacos. So that's region 1. Let me move on to region 2. Those 3 right there. Those 3 are also inside the pizza circle, so they like pizza. They're inside the hamburger circle, so they like hamburger. They're not inside the taco circle, so they don't like tacos. So let me just say this 3. I'm going to say like pizza, like hamburgers, don't like tacos. The next region, which I'm going to call region 3, would be those 2 students right there. Those 2 students are in the hamburger circle. They're outside the taco circle, they're outside the pizza circle. So for those 3 in region 3, those 2, they like hamburger, they don't like pizza, and they don't like tacos. Now I'm going to go to region 4. Region 4, it's inside the pizza circle, it's inside the taco circle, it's outside the hamburger circle. Those 2 like pizza and tacos, but they don't like hamburgers. So for region 4, those 2, they like pizza because they're in the pizza circle. They like tacos because they're in the taco circle. And they don't like hamburgers because the hamburger circle doesn't capture those 2. So I think that's probably enough explanations. Maybe I'll do 1 or 2 more. These 5 right here, because it's inside the pizza, the hamburger, and the tacos, those 5 like all 3, and that's region 5. So for region 5, those 5, I'll just say like all 3. That 1 right there in region 6, they like hamburgers because it's inside the hamburger circle. They like tacos because that's inside the taco circle. But the pizza circle doesn't capture that 1, so those ones right, that 1 person, they like hamburgers and tacos, and they don't like pizza. This 3 students right here, they're inside the taco circle, so they like tacos. The hamburger circle and the pizza circle doesn't catch them, so those 3 like tacos, they don't like hamburgers, they don't like pizza. And the 10 out here in region 8, even though the numbers, as long as it's outside the circles, it's good enough. Those 10 don't like pizza, they don't like hamburgers, and they don't like tacos. So those are the 8 regions that are represented by the diagram. Now let's answer some questions. So, how many liked hamburgers? Well, to like hamburgers, you have to be inside the hamburger circle. So in order to do this problem, how many liked hamburgers, I'm going to focus on the hamburger circle because any one of the numbers inside the hamburger circle counts for a student that likes hamburgers. So I just simply shaded the hamburger circle. And I'm going to count every student that's inside the hamburger circle. So I'm going to go 2 plus 3 plus 5 plus 1. And I'm going to get 11. The answer to how many liked hamburgers would be 11. So hopefully, oh, I just had a hiccup in the video, so hopefully that didn't mess me up. Just in case it did, to answer the question, how many liked hamburgers, I just focused on the hamburger circle itself and added up the individual numbers in the hamburger circle. Next one, how many students liked exactly one of the 3 types, which means they liked pizza but not hamburgers and tacos, or liked hamburgers and not pizza and tacos, and so forth. And these 4 students that were here, it's part of the pizza circle, so they liked pizza, It's outside the hamburger circle, they didn't like hamburgers. It's outside the taco circle, so they didn't like tacos. I'm going to include those 4 students. I'm going to include these 2 students because these guys liked hamburgers because they're inside the hamburger circle. This is outside the pizza circle and outside the taco circle, so they only liked hamburgers. And these 3 only liked tacos and didn't like pizza and hamburgers. So when I'm asking how many liked exactly 1 in a 3-set Venn diagram, these would be the numbers the regions I'd be focusing on. And that's going to give me 9. The ors are the evil ones. How many liked hamburgers or pizza? Or I have to think of as union. So this is asking me to find the number of students in the hamburger circle union the pizza circle. Maybe I don't need that S there. So let me do the union drawing. To do a union drawing, I'm going to first shade the entire hamburger circle using my orange color that I have out today. And it's a union, so I can stay with one color, and now I'm going to shade the entire pizza circle. So or is a union problem. I shaded the hamburger circle in orange, the pizza circle in orange, and now I'm going to add up all the numbers that are represented there. So 4 plus 3 plus 2 plus 2 plus 5 plus 1. And the answer to this is going to be 17 students. Last question before we get into some homework. How many students were surveyed? Well, every single number that's represented in this diagram represents an individual student's preferences that were surveyed. To answer the question, how many students were surveyed, I'm just going to add up all the numbers, and apparently I did that down here. I did 4 plus 3 plus 2 plus 2 plus 5 plus 1 plus 3 plus 10, and I got 30 students. All right, now time for us to do a word problem. So I'll do your problem 1 to get started. So describe what each region represents. Well, I better read the problem first. A group of theater majors were asked whether they were in the drama club or the music club, and the results were summarized in the following diagram. So the left circle represents the students that were in the drama club. The right circle represents the students that were in the music club. So one at a time, I'm just going to go from left to right. This is region 1, 2, 3, 4, but I don't really need to say region 1, 2, 3, 4 if I don't want to. I'm just going to pull out each number. These 9 students right here, because they're inside the drama circle, they're in the drama club. But they're not inside the music circle because the music circle stops there, so they're not in the music club. Done with that 9, moving on to this 15. This 15, it's inside the drama circle, so those students are inside the drama club. It's also inside the music circle, so they're part of the music club. And I'm just going to be lazy. I say those 15 are in both clubs, meaning they're in the drama club and the music club. The 7 over here, it's inside the music circle, so those are in the music club. It's not part of the drama circle because the drama circle starts there, so they're not in the drama club. So those 7 are in the music club, and they're not in the drama club. And lastly, the 12 out here, they're outside the drama circle, they're outside the music circle, they're not in either club. All right, let's try to answer some questions about this now. More questions. How many students were in only one of the 2 clubs? That's these students right there. They're in the drama club and not the music. So I'm assuming this means we're in exactly only one of the 2 clubs. and those 7 that were in the music club but not the drama club. The answer to part B is going to be the 9 students from this region, only in the drama, not in the music, and the 7 from that region in the music, not in the drama, which is going to give me 16. Part C asks me how many students were in the drama club or the music club. To do this, I think of the or as a union. I'm going to, in one color, shade the drama circle to represent all the students that were in the drama club. Because or means union, I'm going to shade the entire music circle in that same color. These would be the students that are either in the drama club or the music club. I'm going to add up the numbers, 9, 15, and 7. I think I get 31 to the answer to that. Last part of this, how many students were surveyed? I just add up any number in any of the regions. So I'm going to add up all 4 numbers, the 9, the 15, the 7, and then this 12. And assuming I haven't made a math error yet, I think that's 43. 19, 29. Yeah, I think that's right. So I'm going to show you number 2. And let you give number 3 a go. So there's 4 regions, but there's only 3 numbers, so you only have to describe the 3 numbers. Out here, you can think of there being a 0 if you want to do a 4th explanation. So here's a group of coffee drinkers again, and they were asked what they added to their coffee. Some added cream, some added sugar, some added both cream and sugar, and apparently nobody that was surveyed took it black because there isn't any number outside the diagram. So give that one a go, and I'll walk through number 5 with you. All right, so number 5. The international school offers French, Spanish, and Japanese classes. A group of students was asked which languages they had studied. Some studied French, some studied Spanish, some studied Japanese. They all studied at least one of those because there isn't anything outside the diagram. So one at a time, I'm going to describe what each region represents. Region 1, 2, 3, 4, 5, 6, 7, 8. And I don't need to give the regions a number right now. So these 23 students studied French because they're in the French circle. This represents what languages they studied. So they studied French because they're inside the French circle. They didn't study Spanish because that's outside the Spanish circle, and they didn't study Japanese. I better get another sheet of paper because I'm never going to fit this. These 20 right here, they're inside the French circle, so they studied French. They're inside the Spanish circle, so they studied Spanish. But the Japanese circle doesn't catch them. So those 20, they studied French. They studied Spanish. And they did not study Japanese. You don't have to go in the same order, it's just the order that I generally go in. Kind of left to right, bottom to top to bottom. Those 32, they studied Spanish because they're inside the Spanish circle. They're outside the French and they're outside the Japanese circle. So those 32 studied Spanish, didn't study French, and didn't study Japanese. Done with that. Now I'm on to those 5. Those 5 are in the French circle, they're in the Japanese circle, but they're outside the Spanish circle. So those 5 studied French, studied Japanese, didn't study Spanish. In the middle, those 4, it's inside the French circle, those 4, it's inside the Spanish circle, and it's inside the Japanese circle. Those 4 studied all 3. These 7 right there, it's inside the Spanish circle, they studied Spanish. It's inside the Japanese circle, they studied Japanese. It's not part of the French, so they didn't study French. So those 7 studied Spanish, they studied Japanese, and they did not study French. Last number, those 9, it's only in the Japanese circle. It's not part of the French, and it's not part of the Spanish. So they studied Japanese, they didn't study French, they didn't study Spanish. So the last number, the 9, studied Japanese, did not study Spanish, did not study French. That was a monster question. Must have taken me 5 minutes to write all that down. So that's part A. Part B, how many studied exactly one of the 3? That means, only one of the 3, and those are really easy for me to tell. These 23 students did only French, but not Spanish and not Japanese. These 32 studied only Spanish. They didn't do French, they didn't do Japanese, they did exactly one language. And these 9 studied only Japanese, they didn't study French or Spanish. So for the exactly, I'm counting those same regions that I've been doing for the exactly. So I'm going to add up 23, 32, and 9, 41, 61. My answer is going to be 64. For C, this has the word or, and so it's a union. So I'm trying to find the region. I'm doing the Spanish union, the French circle. So to get the answer to problem C, because it's an or question, or means union, and the regions that I'm going to count up, I'm going to count up the entire Spanish circle for studying Spanish, and then for the or French, I'm going to count up the entire French circle. So all the numbers that I have highlighted here, I'm going to count. So I'm going to count 23, 20, 32, 5, 4, and 7. Those are the numbers that are represented. So for part C, I'm going to add up 23 plus 20 plus 32 plus 5 plus 4 plus 7, and I feel like I'm going to make a mistake. If I haven't already, I'm going to make a mistake today, and I should just resort to my calculator. The answer to part C is 91 students. D is a little bit tricky because it has an or. How many studied Spanish or French but not Japanese? Not means kind of a complement, and the but kind of means and. So this or is a union symbol. The but is an and the not is a complement. So I snuck in a couple words here that you might be able to answer this question without drawing a picture, but let me try to draw a picture. So what I'm trying to find is how many studied Spanish, and then the or becomes a union French, intersection for the but, and then not Japanese, that's going to be the complement. So that's what I'm trying to find for part D. So let me try to find that as a picture. So as a picture, I'm first going to do the Spanish or French part. And to do the Spanish or French part, I have the Spanish circle. I'm going to color it in. The French circle, I'm going to color it in with the same color for the union. So this is the Spanish or the French part. And now I need to intersect that with the not Japanese. The Japanese circle is down here. The not Japanese circle, the not Japanese drawing, is everything outside the Japanese circle. Now, because it's an intersection, I need to figure out the regions that have both shadings, and those are the regions I'm going to worry about. So there's a French, a Spanish, and a Japanese. If I look at my drawing, the union first in pink, and then the intersection in green, the regions overlap there. Those are the numbers I'm going to add up, because those students up here, those studied French and Spanish, and none of them studied Japanese. So I'm going to add up the 23 in this region, the 20 in that region, and the 32 in that region. So I'm going to take 23 plus 20 plus 32, and I think I get 75 as my answer to part D. So I'm already 40 minutes into this video, and I'm really just starting on this section. I think it would be best for me to break this video up into a part 1 and a part 2. So make sure you kind of have this part of the video perfected, and then we'll move on and we'll do a part 2 as opposed to making this a 2-hour video.